We'll be covering GIS Basics, and eRAMS was started about 2008 as a research tool in which CSU faculty have been working over the past 8 and 9 years to really develop an open source platform for sharing data on water and land systems, really across jurisdictions, across boundaries, across all sorts of things. Having this open source platform is critical. And it's been identified as this not being able to share data systems has been identified as a true obstacle to getting to better water management. So as we take eRAMS from a research tool to an application tool, we're hosting these webinars to get folks used to our systems, let them know that it's out there. So we invite any questions and suggestions that you have as we go through this. So as we get started, Tyler Weibel is a developer with the One Water Solutions Institute at CSU. He has developed a number of applications on eRAMS and tools. And the last one we were asked if we could do a session just on basic GIS in eRAMS. And so that's our topic for today. This will be recorded and made available on the One Water Solutions Institute YouTube channel, and when that is available, we'll send you that link so you can refer back to it. So with that, I'm going to hand it over to Tyler. If you have questions, if you have any other suggestions, just send them to us through the chat box, and we'll take it as we go. So Tyler, do you want to take over?
Sure. So are you guys already seeing my screen? The eRAMS? Okay. So this is the basic interface for eRAMS once you get inside after you log in, or whether you're looking at any sort of project. But today we're not going to be covering a project in specific. We're just going to be working with the base GIS data, the base layers, and some of the root functionality of doing shapefile intersection, how to upload a shapefile, how to do time series, how to do labels and symbology and that sort of stuff. So I'm going to start with just a quick overview of the toolbar up here at the top. This first one is basically the eRAMS toolbox itself that gives you access to basic tools like how to measure something. If I want to go through and measure a distance on a map, if I want to see how far it is from Federal Boulevard here all the way over to the end of 26th Avenue, you get this nice little pop-up over here that'll tell you that it's basically a half mile. It'll also pull out and summarize the elevations in there too. You can also use the measuring tool to do an area, so if you want to see how big a square block is for a given area, you can draw that out and get a total area summary. There's numerous other tools available in this toolbox, and we'll go over some of them today, but it includes the ability to extract data like climate data, like stream monitoring data, DEM data, soil data. It also has the capacity to do some more analysis components for hydrology to figure out curve number and those sort of things. And like I said, we'll also go through some of the geoprocessing in here as far as overlays and intersects and buffers and that sort of thing. But that's the toolbox. This next guy is the pan tool, which basically allows you to pan through the map just like in Google. You also have your zoom bar over here that you can zoom in and out. Your scroll on your mouse will also do a zoom in, zoom out. To zoom to a specific area that you want to draw, you can use the zoom tool and just say you want to zoom over here into this section of Highlands Park if you want to look at the high school it looks like. You can also zoom to the previous zoom level. So if I want to go back to what I was just looking at, I can hop back pretty quick, or I can hop forward to that if I've zoomed a few times and go just straight back to what I was looking at. You can also zoom to the extent of all the layers that you have uploaded in a given project. This particular project doesn't have any uploaded yet, but I'll run you through that here in a bit, so that one won't do anything at the moment. And we've also got an inspect feature that will let you identify and summarize it. So once you have a polygon up there or a point up there, you can select it and see its attribute table and a little bit of summary about it. You can also query the database. You can start a query to figure out if you have this shapefile, I want to select or view all attributes that have name equal to Colorado or something like that. And you can remove those selections also. You can also erase any selections or graphics that you've done as far as buffering and measuring using the little broom there. You can also go through and add point data. You can place a place mark on the map, which is basically just a placeholder. You can tell it to save where you're at. And you can also use the layout view to print a given map. So if you've uploaded and messed with your symbology, you can go through and actually export that map as an image, just like in ArcGIS, so you can save it in a report or something. That's basically the toolbar up here. If there's any questions on that, feel free to type them now, and I'll give you guys just a sec to go through and do so. I'll keep an eye out if anyone's got any questions, but I'm going to move on to the base layer section. So this is the map tab. All projects on eRAMS have this map tab, where you can go through and you can specify the units that measuring tool is going to be using, the scale that you're zoomed to. So you can change that to whatever you want if you're working in metric or if you're working in English. But the next one I'm going to talk about is the base layer. So you can modify the image back here that's sitting behind all of your uploaded data. You can make it absolutely nothing. You can toggle between some of the different options we have, like OpenStreetMap, which is a product out of Europe. You can do just exactly the Google Maps if you want a physical map, if you want the street map only, or if you want a hybrid between the street map. We've also got Bing, and then we've got a few of these others from USGS that include topographic maps and imagery topos that are a little more detailed, that they have the background streams, they have the elevation lines and that sort of thing. You can also do hydrography, which will simply show you the watershed boundaries that you're viewing for a given area. You can mess with that one as your background map. After the base layer is basically how you can access all the different layers. We have a number of different data sources preloaded into the eRAMS front end, which include, I'm going to switch back to Google real quick, which include census data, so that you can zoom in and view census data. Say I want to zoom in and look at Berkeley, Colorado here, and look at 2010 census data for not the state and the county, but the more block tract level. What that's going to do is it's going to go fetch the census data and then summarize it based on population density, based on whatever metric you're interested in for that area. You can also go through, and once you have this, the data showing up, you can extract it. So if you wanted to save tract level data or county level data from the census, you can pull out the population summary, you can pull out the age summary, you can pull out housing for a given area that you define on the map, whether that's something that you draw like a polygon or a rectangle, say that I want to extract it for just that area, or whether it's a layer that you've uploaded. You can specify what layer that you want to extract this data for. And this option is available for all of the different public data layers. So besides just census, we also have a number of databases under this US Geodata that include highways, that include rivers, that include transportation. So you can go through and you can check these on and off, and you can view the watershed boundaries, you can view the flow lines themselves, the water bodies themselves. So you can kind of view, and they all have these little labels on them so you can read what they are. And again, if you wanted to, say, download the HUC 12 watershed boundaries for whatever area you're interested in, you can go and use this extract layer option, and it'll be real similar. You can specify what you want to select to download, and if you use a control select or a shift select, you can select more than one thing and then download that for the given area of interest. We also have all the highway segments. We have airports, we have railroads that you can map out on here. You got the U.S. Forest Service trails. And again, this is all just preloaded data that helps begin to assemble the tools for someone to sit down and start analyzing a watershed. We also have a number of others, including just the geographical stuff as far as locations, continents, that sort of thing. And then we also have all the governmental boundaries as far as, is it a city, is it an incorporated place, is it a reservation, is it a county, is it a state, is it your congressional districts. So you can play with this in your downtime just to get a little more familiar with the different options here in the public layers. We also have access to the US EPA water data, so you can look at different STORAT monitoring locations that might be in the area. You can look at some of their beach and NPDES monitoring locations, and you can also extract them same way for the rest of those. One of the more interesting ones that I like playing with is the land cover data set. So we have pulled in both NAS and NLCD land cover data sets from the USGS and the USDA that you can view it. So if you want to just go through and view the NAS data for this, you can view that this is categorized as an urban area with a water body and some other categories thrown in there. And if you want to change the year that you're looking at, you can specify whether you want to look at 2014's land cover, if you want to look back at maybe 2009's land cover data. You can also do that the same way for the NLCD stuff, that if you want to look at just 2011 as far as the lower United States, or if you wanted to look at, say, 2001 for the lower United States. And you can, again, download this stuff if you wanted to summarize it or access it or analyze it offline or online, or to have a local copy of it. You can use this extraction tool to extract out the 2011 NLCD land cover data set for whatever area of interest you're interested in.
So Tyler, we have a question of when you download the data, when you extract it, what do you get? Do you get a shapefile? Do you get a graph? Do you get a CVS
So that
file?
depends on the data set. So in the case of NLCD data, the land cover data set, these are rasters basically, so they're GIS raster values. So what you would get is you would get a TIFF file, a .tif file, that is a raster that you can use with ArcMap, ArcGIS, Google Maps, Google World, that sort of thing. If you did it for some of the geodata sources like the water bodies or the watershed boundaries or the flow directions, what you're going to get is you're going to get a polygon shape file or a point shape file or a line shape file. I hope that answers that question. Let me know if it doesn't.
Yes, thank you.
That is a good question. So that's basically this public layers section where we have a whole bunch of preloaded data that's available to you guys to download, to view, to extract, to summarize. And it's a nice starting point for any sort of watershed analysis or any sort of map-based analysis. The next thing that I'm going to move over into is how to work with layers, how to upload your own data, and how to mess with your own data. So we have, when you're logged into eRAMS, you've got two different places you can put this. You can put your layers under your user layers, or you can put them under your project layers. Now the difference between these two locations is, as a user, you can have multiple quote-unquote projects. This is my default project. Nice fancy name that I gave it. If I upload data to the project layer, it will only exist inside of this default project. If I upload data to my user layer, it'll be there in every project that I create as a user. So if I have this project that's default, if I have a RAP project, if I have a flow analysis project, if I have some map project that I'm sharing with someone else, all of those would have the data from my user layer inside of it. So it tends to be helpful to keep it under the project, but sometimes there's a use case that you might want to have, like if you're working exclusively on some watershed, to have the boundary of that watershed available for multiple projects rather than uploading it 6 times kind of thing. Now as far as uploading a layer, if you click on the spatial layers here, you'll get the option to add a layer. And this can take, like I said, a raster file, so it'll take that TIFF file and it'll upload that for you, or it'll take a shape file. Now for shape files, we recommend zipping them all together. So you zip up the .shp, the .sbx, the .dbf, all of that mess of all the different files that Edgery does, and you stick it into a zip file. So inside of this zip file here, you'll see that I have all of those shape files, and what it's going to do is it's going to upload it, it's going to automatically unzip it, and then it's going to stick it in my project layer. And you can go through and you can upload the one, you can upload a second one if you're interested. And those are
Tyler,
going to
we
load
have
here
a
for... Uh-huh.
Do you have soil layers too, as you're going through that?
So we do have soil data. I believe that you can extract the soil data on this side of things. So if you go into the toolbar for the main tool map right here, and you go to extract data, and you go over here to Surgo soil data, you can extract Surgo soil polygons and their respective data using the soil data mart service that Surgo set up. It's not necessarily over here on the public layer side of things. It's a little more complicated than that. But you can access it and view it there. Now that I've uploaded my 2 shapefiles, you'll see that they show up here under my project layer. One of the nice features is if you click on a given shapefile, you can go over and you can zoom to it. You can also re-download it. You can also check on what you've selected out of it. You can add time series data to it. So if you have a series of monitoring points that you're monitoring for water quality or whatever you're monitoring there, if you have a point, you can upload the shapefile of those points, and then you can upload the time series data for those points. You can analyze those together and keep them in the same spot. But I'm just going to zoom over into the 2 layers that I've uploaded so far. So you notice that I've got a multi-polygon in layer B and just a single polygon in layer A.
And Tyler, if you have a chance, could you kind of go over how to do that time series again? Just, it was quick,
Yes.
so if you can show us again, that'd be great.
Definitely. The time series isn't actually explicitly in this demo, but I will definitely make a note of that towards the end if we have some time. With the shapefiles, the first thing that you do when you've got your maps all set up is you probably want to play with the symbology a little bit. So if you click on the symbology, just left click, you'll get this nice little window that summarizes the layer, and you can go in and you can change the symbology. You can set up multiple symbols. So like I've got 2 polygons here in this layer B guy. So I could set up natural breaks based on the name of the polygon. And I'll have polygon 1 and I'll have polygon 2, and I can edit those independently. So if you click on the symbol here, you can go through and say, well, I want it to be a red polygon with a black border outline. It's a little bit thicker than what that is. And then you'll update it and you'll apply it, and then this guy will turn red. And then you can change this guy to be something else if you want it to, say, be green. That's pretty much how the symbols work. Pretty straightforward. If you have point data, so one example is, let's say you have a list of lat-long monitoring locations, but I don't have it as a shapefile. What if I only have it in a CSV file? I've got a CSV file over here on my computer that I'll show you guys real quick. It's basically a list of my location IDs, then I've got their lat-long locations, and then I've got just some attributes about them. Well, the problem is this is a CSV file. What if I wanted to view that here on the map? You can do that. So if I click on a table, because a CSV file is basically just a table as opposed to a spatial layer, I can upload a table the same way that I uploaded my shapefile, but instead this time I'll pick that CSV file, and then I'll get my little table over here. If I click on that, I can turn that into a layer. There's an option to do that, and then once you choose that, you can specify your datum that you're using, the coordinate system. We're using lat-long as opposed to UTM coordinates, and my x-axis is going to be my longitude, my y-axis is going to be my latitude. So if you have those 2 pieces of information, what you can do is you can then generate this point shape file. So I now have my point layer in my spatial layer because it's no longer just the table. I also created a shape file out of it. You'll notice that they're a little bit hard to see, so I can hop into the point symbology, and I can click on the points, and I say, well, maybe I want them to be a bigger point, so I could just simply make the dots bigger on the map. Well, we also have a number of options in here that you can go through and pick different symbols. So if you wanted to, say, make it a pin, you wanted your pin to be visible, you could pick a pin as that, as opposed to just a simple GIS dot. It looks like we have another question real quick. Teresa, could you read that off?
Yeah, do consistent projections happen automatically when different GIS layers are pulled in?
Yes. So when a layer is uploaded into eRAMS, eRAMS auto-projects it into that, I think it's WGS 84 is everything that eRAMS operates on. So yes, whenever you upload a project, it's going to get auto-reprojected into that, so you're working off the same coordinate system.
All right, thank you.
Okay, so just like the polygon data, you can go through, you can play with the symbology for the point data, and we've got all sorts of just preloaded pictures of what you can mess with. I'll leave it as the pins just because that's a little bit generic. That's basically the symbology and the different classifications that you can do, so you can classify out polygon 1 versus polygon 2 for editing purposes. One of the next thing on our agenda is basically working with the attribute table of a polygon layer. So we've uploaded the spatial side of it, but how do you view the actual attributes attached to these files? Well, if you click on that layer again, you'll have this option to open the attribute table. What that's going to do is it's going to just pop it up just like it does in ArcGIS, give you a summary of what was there. Well, in this particular one, we've got the names of the polygons. We've got a couple of attributes about them. You may be asking yourself, what if I wanted to, say, add a new column and edit it, and how do I mess with that? So if you go to your options over here, you can add a new column. You can say, maybe I want to just add a column that's going to be my test, that's going to contain some text in it. And that'll create this test column that you can then double click on and enter information. And then I can click on the next one and add something else. And I can save that. You can also undo all of these operations until you save it. That field, those edits, they won't be saved in this table until you save it. But once you save it, it'll save it into that attribute table for you. So that's how you go about creating a new field, doing something with it. What if I wanted to then create a new field that was dependent on the other field? So what if I wanted to create like a math function? And I wanted it to be some sort of real number based on attributes 1 and attribute underscore 1. What I can then do is I can create that field, and then I can use the field calculator tool to go through and say that this particular field is going to be attribute 1 plus attribute underscore 1. And I can go through and calculate that, and it'll summarize those out for you. So you can do a lot more of those complex math options using this field calculator. You can do, we have all the basics, the rounding, we have sine, we have cosine, we have exponential, we have powers, we have addition, subtraction, all of that. So this is just like the field calculator that ArcGIS has. So you can edit a shapefile in the same way in eRAMS that you can in ArcGIS. And again, the edits to this column won't be saved until I click that save option. Any questions so far on the field calculator or how the attribute table works? I'll keep an eye out. One of the more useful ones that's always nice to do is to be able to calculate the geometry of your given object. So I may have a question of how big is this circle versus how big is that triangle. eRAMS can calculate geometry. So if you create a new column and you say you want, call it whatever you want, so I'll call it mine shape area. If you set it to this area attribute and accept it, what it's going to do is it's going to tells eRAMS on the back end to calculate the area into this. So if you save it and then reopen the table, it's going to summarize out the area for each of those shapes. And this area is calculated in square meters. So my first shape, shape 1, is apparently 15,000 square meters versus the other one is 26,000 square meters. And the same thing works for perimeter. So if I went in here, I wanted a perimeter instead of an area, I could create a perimeter option. And then once I save it and then close out of my attribute table, then reopen it, it's going to be there and have the calculated perimeter of the given polygon that I've got in there. So I've got a 606 meter perimeter versus a 578 meter perimeter. One of the cool things that we've added on top of the attribute table is we've got these summary statistics. So if I wanted to look at my perimeter attribute here, I could look at the statistics of all of the attributes in this column. Now granted, I only have 2 polygons in this, but say you're looking at 100 of them. You can get this summary statistics file that you've got all the base statistics, the min, the max, the mean, the median, some percentiles. You've got a nice little box plot over here that summarizes it. You got a histogram at the bottom, and you can dictate how big that histogram is if you want it to be smaller or bigger as far as how big those bins are. But you can view that for any sort of numerical value in your attribute table. Now again, this is just a simple 2-item example, so it's not all that informative, but it shows you the capability that you have. And you can also print this out to a PDF report summary if you really want, and save that somewhere. Stick it in your report that you've got to send off to NSF or something. If there aren't any more questions about the attribute table, I'm going to move over to how you query and select things out of a shapefile using the query builder that we've put in eRAMS. So the query builder is this guy over here. It's the database query. And what it is you can save your queries. You can say, well, maybe I was working on some project that I had to select all polygons over a certain size that were located in Colorado that had 90% male population or something like that. You can also just create a new one. So what you do is you define the layer you're querying. So I'm going to keep working with this layer B because I got 2 things to select from. Move on to the next step and say, well, what do I want out of layer B? Well, what if I pick the name of the name attribute? So these are the different columns. What if I want the name of polygon 1? I'll select polygon 1. You can also add a spatial type, so you can do the attribute side of things or you can do the spatial side of things. And you can run that query, and what it's then going to do is it's just going to simply select that polygon number 1. So you notice it selects it. If I hop back over to my project layer over here, you'll see that you can change the symbology for those selections as well. So if I wanted to say make it a bright red selection instead of a yellow, since the layer under it is yellow, I could change the selection to a red. And that doesn't change the base symbology of polygon 1 and polygon 2. It just simply changes the selection symbology. So that's how you can mess with a selection. Now, once I have something selected from this layer, if I want to export it into its own shapefile, you can do that. You can click on that, and based on your selection, you say, well, maybe I want to create a new layer. I'll call it layer B selected. What that'll do is it'll export that into its own layer sitting over here that is layer B selected. And I can go through and mess with its symbology too. Switch that maybe over to just a single symbol, update the classification, and then make it a purple instead of what it was. So you can now see that I have my layer B that has my first polygon, my second polygon, and the selected one of them. And then I have my exported layer B selected, which is only just the circle. I believe that is pretty much everything in the selection side of things. The next thing I'm going to show you is some of the options that you can mess with as far as intersections and unions and merges that you can combine and work with your polygon data. So all of that is housed in our eRAMS toolbox over here under the geoprocessing side. So if you go into the feature class, feature class like polygons, points, lines, as opposed to rasters, there's a number of different options that you can do. If you look at the overlay options, you can do a clip option. So if I wanted to say clip my A layer, this yellow one, if I want to clip that to just this purple one, I can clip layer A to my selected layer B, add it, and then I can clip it. So what that'll do is it'll just keep the clip between the rectangle and the polygon over there. And you'll notice that while you're working in these, it grays out your ability to mess with the map tab because you don't want to be messing with the layers while you're trying to clip the layers. But once I click off it, you'll see that I've got my little clipped section of layer A now. I can also go through and go to some of the other examples and use, say, if I wanted to intersect them. If I wanted to intersect, layer B, just all of layer B, both the circle and the triangle, against my layer A, I'd add layer B as the layer I'm intersecting against and select layer A as the one I'm intersecting against. And once they're populated here, you can then intersect them. And again, this is set up super generic, so if you wanted 2 or 3 or 5 or 10 shapefiles to intersect against each other, you can do that. And once it does that, you'll notice it saves it out. Now I've got my little intersected guy, which I can change the symbology real quick to be something else so we can kind of see that it's a different layer than the others. So that's the intersection of those two. We've also got merge and union, which have slightly different GIS sort of functionalities than intersect does. But you can take, again, layer A, and maybe I want to take layer A and I want to union it with the selected layer B guy. And again, you can select as many layers as you want, or you can draw custom ones. And then you can perform the union, and it'll spit that out and save it. So I've got my nice little union guy over here. I'm going to turn a few of these off. So if you check the box, by the way, I think I skipped this at the beginning. If you check the box next to layer, that's a view, hide, show kind of thing. So if I unselect basically everything, it'll go back to just the base layer so that you can examine, say, just the intersected one or just the unioned one. So you can view and hide and show that sort of stuff. We've also got these little plus minuses next to all of these guys. This is a minimization of the legend item. So if you wanted to minimize all the legends and just look at the names, because we're starting to get quite a few layers here, it gets a little bit long on your computer screen. You can zoom in and out like that, so you can just look at Union 1, or I want to just look at the layer B selected. We also have inside those feature classes, we got the merge. Merge is real similar to union, but I mean it functions just a little bit differently. So if I wanted to grab layer A and merge it with layer B, then I can just select both of those, add them to my list, and then just merge them. Any questions on the geoprocessing sort of side of things as far as the layers? So once you have all your layers uploaded into eRAMS, you have a number of ways to manipulate and edit them that you can use or not use. Or we also have, like I said, we also have the ability to do proximity stuff. We can do buffers. So say I've got whatever area that I'm interested in, I want to create a buffer run. Say I want to see everything that's within, I don't know, 100 meters of this circle. So if I wanted to specify layer B selected, because that's my circle guy, right? Just the purple one over here. If I wanted to buffer that out into its own layer, I can create a new layer that is simply the buffer that's bigger than that. So I got a nice little layer. So everything that's within 100 meters of layer B. You can do that for the lines, you can do that for the points, you can do that for the polygons. Now you notice in doing so, I kind of covered up that purple one. Well, what if I wanted the purple one to show up on top of the red one? That's kind of an order in the legend. You can grab these guys and you can drag them up and down this list. So I can put purple back on top of the red one and I can see both of them better. So you can order all of your layers just like you can in ArcGIS to view which one's on top, which one's below, kind of thing. Now that I've got that buffer, I can also use, say I want to use the erase tool. You can also dissolve out. So if you had a whole bunch of polygons and you wanted to dissolve stuff for them, so if you wanted to dissolve all the counties in the country into just the states, you can dissolve by their state attribute, and you could do that using this tool. I forget where erase is. I'm sorry, bear with me for a second. Okay. Any questions on the shape files, the symbologies? I think I made a note that if I was gonna, if I had a couple extra minutes, I was gonna show you the time series stuff. So one of the things I mentioned earlier is the ability to add time series to something. So if you select a given layer, and you have this time series data option. So what's going to pop up there is how to interact with it, how to view it, how to work with it. So you can upload your time series, and it's going to give you instructions on the CSV formatting or the tab delimited formatting that you have for your shape for whatever data you have. I don't actually have any ready on hand, unfortunately, but say maybe I'll upload the my points data. It'll upload all of that in, and then it'll ask me if I want to post-process that. So what sort of format is it? Is it a USGS NWIS file that is already a pre-formatted one, or maybe it already fits the EPA STORET database formatting setup? We've already built those compatibilities into here so that if it's set up with the same water quality codes as USGS, or if it's set up with the same water quality name, the naming conventions and site names and lat longs and all that as STORET, you can pull that in that way. And once you have that, you can save your time series data. Once you've saved your time series data, you can then go through and select and view it for a given polygon. So you can attach a time series per polygon route. So if I had a point layer here with 10 monitoring locations, I could upload one time series to one point, a different time series to a different point by just selecting the layer that I'm interested in. And then you'll get a table summary of that data, and then you'll also get a graphical summary of that data. And it'll look real similar to the attribute summary that I showed you earlier, that you got the basic statistics, the box plot, the frequency plot. And in this case, if it's time series, it'll give you a time series plot of daily time series, or whatever you've uploaded in there. Does that answer the question on the time series?
Yes, it does. Thank you, Tyler.
Sorry, I don't have an example ready for that one. That one slipped off of today's to-do list. So I'm going to open the floor and just leave it up to you guys. And we've got a few minutes left, so go ahead, ask me any questions as far as how to interact with these layers, what sort of public databases we have, how do you download them, how do you work with any of these things. So I'll open that up for you guys to ask.
So Tyler, one question would be, once you produce a layer, is there a way to share that layer with others? If you're on a research team or something else and you want others to see your layer but maybe not the whole, your whole project?
So yeah, you can do that. So one of the things that you can do once you have this project, this is my little default project. If I go over to my account page on eRAMS, this is kind of more outside of the map view side of things. On this project tab, you'll see that I've got my default project right here. One of the options that I can do is I can share this project and make this an active link. So if I wanted to share this project, this link will simply take me off to that project. But as the owner of this project, if I go back to it, I can look inside of here and I can individually share or not share the layers inside of this. So right now, all of the data inside of my spatial layers is shared. Well, maybe I don't want to share the buffered layer that I did. Maybe I don't want to share the merge layer that I did. I can simply click these and go through and share whether or not they can view and see these things when they go to that link. So that would be a way that you can share a given project with multiple people that they can see and not see, and view and not edit certain layers. Another thing that we have in eRAMS is more of a collaborative environment. What you can do is you can set up a group on this group page. So you can create a group, and that group can control projects, and you can control who's in that group and what sort of access they have to that group. So if I go into the clean project that I'm associated with, you'll see the list of all the different people on here, and you can edit whether they're a full administrator of this data, the project, the documents. If they can add, they can upload, they can modify, they can delete, or if they're a view only, maybe you have some people that are directly working on compiling the data and they need to edit it, but you have another group of maybe stakeholders that simply want to view it, but they shouldn't have rights to edit it. You can go through and create a group here, and you can give the stakeholders just view only permissions. You can give the workers full access. So I can look at Dr. Bledsoe over here, and I can make him a full access or a read-only access for this particular project. Does that make sense?
It does. Thank you. And also, I guess, Tyler, if when we go to work on the classic project, which is, we'll be getting data from communities on green infrastructure stuff. Is there a way that we can map one community's green infrastructure and just share that with them and send it to them to review it? Would we just send them a URL, or would we have them actually sign up as a user?
So you could do that either way. You could have them set up an account on eRAMS, have them log in and view and or edit the data depending on what sort of structure you wanted them to QA, QC, the green infrastructure that you outlined. Or you could simply share that URL link that I created. So like for this particular project, this default guy, I can go back and I can copy this to my clipboard. And if I open, say, a different web browser, because I'm already logged in on this particular web browser. So if I hop over to a new web browser and go to that link, I can show you the public-facing side of this. It'll take me to that default layer, and it's going to show, oops, looks like I deactivated my link. Let me reactivate that real quick. Sorry about that. So if I go to my project, and this is a shared resource, so it should be active, I'll make sure that it's active. I can hop over here, refresh trying to go to it. Sorry about that. But what you can do is once you've shared that layer, this is the public side of it, and it'll give them a unique key. But basically, they can go in and they can look at all the data. This is a different project that I've got that is a bunch of irrigated versus dryland agriculture for the South Platte River here in northern Colorado. So there's a lot of data in this particular one. But from the user perspective, every single one of these layers is saved. And they can view it, but they can download a copy of it if they're really interested. But they're not allowed to edit it. Any edits that they would make to this particular project won't be saved in any sort of way. It'll only exist as long as their web browser is still on that page, if that answers how the group side of things would view shared projects.
It does. Thank you. Any other questions from our attendees down there?
And if you have a special request to something that you'd like to see me demo that I haven't so far today, we've got a few extra minutes. I'd be happy to show you something.
Could you show us the watershed delineation tool, do you think?
I can. So the watershed delineation tool is one of the tools that's available in our toolbox down here. It's in the hydrology side of things. We have a number of things. I presume we're actually going to set up a webinar at some point just on these hydrology tools. But the watershed delineation tool basically has a complex and advanced options to delineate a watershed. Say you want to know how big is the upstream catchment of the area that I'm putting this bridge over, or that I'm analyzing for my research project, or whatever it is. It's real helpful to have a watershed boundary. So I am going to move out to a place that I know a little bit better so I can pick a good river example for you guys. So if I hop up here to Fort Collins, a little bit further, and say that I want to examine this particular watershed. I know there's a creek right up here, right off the Thompson. What you'd first do is you'd create where you're going to store all of this data that you're extracting. So I'm going to create that watershed, and then I'm only going to do the watershed delineation. I'm not going to do the full complicated step-by-step. I'm only really interested in what the overall polygon for that given watershed. So what it's then going to do is it's going to ask me for an area of analysis. So I know that this watershed doesn't extend much past these mountains, so I'm going to delineate out that is my area of interest. Then I'm going to create an outlet layer and say that the outlet point for my watershed is down here, right here at the edge of Cedar Creek, right here going into the Big Thompson River. I'm going to pan just a little bit more, get a good point. I'm going to mark it right there. So I'm going to say Cedar Creek out, drains right there to the Big Thompson. Actually, I don't like that spot. I'm going to make it slightly better. I'll put it right there. Looks like I need to reselect my area of analysis real quick. I'm going to redefine that. Use that whole guy. Then what it's going to do is you're going to extract the watershed. So what this does behind your back while it's running is it goes out and pulls the NHD Plus version 2 digital elevation map, DEM. So it's a 30-meter DEM of the entire United States. So it clips that to our area of interest, and then what it does is it takes that outlet point and it works its way back upstream from there, trying to figure out what is in the watershed, what isn't in the watershed, what drains to this point. So it does all of the fill the sinks in it so that you have a continuous flow path. It does a lot of different steps behind your back, which you can do by hand if you want to control more detail under the advanced option here, or the basic option. But if you're just doing the simple watershed extraction, you can just simply select the area you're interested in and let it delineate it. It is a little bit sensitive to the outlet point location. Sometimes you don't get that point exactly on the river. It doesn't sit exactly right on the river, so you might delineate the wrong watershed. You might delineate the hill next to your stream rather than the stream itself. So you got to be a little bit careful how you place that outlet point. But it'll chug through this for a little while, and then once it's done, it'll give you a polygon that is the watershed boundary. So there we go. That's Cedar Creek. And if you notice, in my particular example, I didn't quite go high enough on my area of interest, so it clipped the watershed to exactly where my area of analysis was. You can tell that there aren't straight lines in nature, let's all be honest. There's probably more of the watershed over here and over here that I missed by clipping it to that area of analysis. So if I wanted to do it again, I could redefine my area of analysis to be a little bigger. And maybe that time I'd get the whole watershed and just the clip instead of just the clipped part. Does that answer that question?
Yeah, and you can save that shapefile to use it in another project.
It's already saved.
Okay.
So if I go over here to my project layers, this part, this watershed folder that I created, that created a folder here in my project called the Watershed October 14th, blah, blah, blah. It shows you, it has my outlet layer in that. It has my watershed boundary in there, and then it's got the raw outlet location. This outlet moved is one of the automatic steps that you can control under the advanced side of things. But it automatically tries to snap the point that you drew to an actual streamline. Okay. So that it delineates the watershed better. But yes, you've already saved this. So this watershed guy, I could then download that shapefile and use it on my desktop computer and inside of ArcMap or whatever, or I could then save it and share it with a different project so that it's inside that project if I wanted to then summarize it in the flow analysis tool or the RAP tool or use it somewhere else. It's already saved. It already exists as a shapefile.
Okay. We have a couple of other questions. Sarah, do you want, or Chris?
Go ahead. So one of the questions is, can you group NLCD land use categories into a single shapefile, such as individual crop land uses into a general crop land use? And can you do this from public layers, or does it need to be exported to a project layer first?
That is an excellent question, and I know the answer. So the short answer is that it has to be in a layer that you're operating with. This is just kind of a hide show thing on the public layers. You don't actually have access to modify any of this data. But if I were to look at, say, the 2011 land use and I wanted to extract it, so the first answer is yes, it has to be on the extracted side. So if I select the area that I'm interested in, and I'll just do a real simple poor rectangle and save that out to my workspace, it'll tell me that it saved it out. I can close all my public layers and go back to my project layer. You notice I'll have this NLCD guy. One of the tools that we have here in the geoprocessing side of things for rasters, because this is a raster data set, is you can reclassify that. So if I wanted to go through and reclassify my NLCD data set, I could do the natural breaks in all of it. I could do So it looks like we have 1, 2, 3, 4, 5, 6, 7. If I wanted all 7 categories, I can update it to all my categories. And you can define the value range that you're going to override. So if I wanted to make just the 21 classification, and I wanted to call that one 5 instead, oops, 5. I won't use stay. There we go. Got to hit enter. Sorry. I haven't used this particular one very much. But you can go in here and you can edit. So if I wanted to just make it classification 21, which if I remember is one of the urban development density classifications. If I only wanted to change classification 21 to 9 instead of class 21, then I could change 22 over to 15 or something. What that's going to do is it's going to reclassify that raster into these values. That is not a polygon layer, it's still a raster layer, but it's a step down that path to reclassify. Like if I wanted to just take all the urban and make it one classification and all the forest and make that one classification, this is where you would do it in the reclass tool. Does that answer the question, Sarah?
I'll wait for a response from Hayes. You said, yep. So one other question, can you run simulations on eRAMS, say the way you do using SWOT?
We have a number of different analysis tools in eRAMS that we've pulled in over the years, and we're continuously working on more. SWOT is one of the projects that is currently working its way from our development side of things onto the production site, this site. We have a simplified version of the SWOT tool that pulls in, that auto-extracts based on Surgo soil data, based on climate data, based on all of that, land use. It'll auto-create a SWOT project and all of the input files and then run the model for you for a given agricultural field. We also have another SWOT tool on eRAMS that's working its way up from the development side that you can upload all of your own files from a SWOT project. You can view it, you can edit it, and you can run it. Those aren't 100% functional at the moment, so they're not on the production site, but those are examples of tools that we are working towards to include in eRAMS at the moment. Does that answer the question?
Yes, it sounds like it does.
Cool. Doing good on my questions so far today.
All right. Well, unless there's any other questions, I think we can wrap up. Tyler, did you want to offer any last words on basic GIS functions?
I'd say get in there and play with it, and if you have any questions, please feel free to email us, and we're happy to answer them. For the most part, eRAMS has many of the functionalities that ArcMap already has, as far as the clip, as far as the intersect, as far as the union, as far as how to query a layer, as far as we've also compiled a huge database of this public layers data that is just readily available for a user to extract and download and use in ArcMap, and it won't hurt our feelings if you prefer to use it in ArcMap, but it's just there and available for you to use to whatever end that you're interested in. So feel free to let us know if you have any questions.
So as follow-up, we have been recording this, and we will convert it over to a YouTube video and send you the link, send everyone who attended today the link to this, or to the YouTube video. And we will be scheduling these webinars on a monthly basis, the second Friday of every month. If you have suggestions for topics or have any questions you want us to cover, just let us know. And you should be getting a survey. It might not come immediately after the thing, but we'll be asking your feedback on the webinar, and if you have any suggestions. So stay tuned for more information, and if you have any questions or suggestions, feel free to send us an email, or let us know. Go to our website at erams.com or One Water Solutions.
And those suggestions can include anything from tools or features in eRAMS that you think would be valuable to learn about or add to, does this webinar format work for everybody? Is this a nice format to send out this information?
So yeah, just let us know. And with that, we'll end today's webinar. Thank you, Tyler. We appreciate it.
Happy to answer any questions you guys have. Before you guys go, you're welcome to, let me just pull up something. I'll give you my email if you do have any questions about particular if you do have any particular questions about the functionality or the tools, I would be more than happy to answer them. That's my email if you want to send me anything. Thanks for your time.
All right, thank you, everyone.